Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. MCPBA is a peracid that performs epoxidation of alkenes, converting the C is equal to C double bond into an epoxide with retention of the alkene's geometry, SYN addition of oxygen across the double bond. Step 2, H3O+, is acid-catalyzed ring opening of the epoxide. Moving on to the next step. The starting material is 1,2-dimethylcyclopentene, both methyl groups on the double bond. MCPBA adds an oxygen atom across the double bond in a SYN fashion, giving 1,2-dimethylcyclopentene oxide, an epoxide. The oxygen bridges C1 and C2 from one phase. Moving on to the next step. Under acidic conditions, H3O+, the epoxide undergoes ring opening via an SN2-like mechanism with water acting as the nucleophile. The nucleophile attacks from the back side, relative to the epoxide oxygen. Since the epoxide oxygen was added SYN, from one phase, the water attacks anti to that phase, giving a trans-anti-diol product. And for the final step. For 1,2-dimethylcyclopentene oxide, acid-catalyzed ring opening gives the trans-1,2-diol with the two of groups in a trans-anti relationship to each other, and each OH is trans to the methyl on the same carbon. Because the ring is cyclopentane, the two of groups end up on opposite faces of the ring, trans-diol. The two methyl groups, originally on the double bond, end up one on each carbon with defined stereochemistry. Option B shows a cis-diol, both of groups on the same face, which would result from OSO4 or KMNO4, SYN dihydroxylthione, not from MCPBH3O+. Option A and D have incorrect stereochemical assignments for the methyl OH arrangement. Option C correctly shows the trans-diol. The two of groups are on opposite faces of the cyclopentane ring, consistent with anti-addition of water to the epoxide. The methyl groups and hydroxyl groups in option C reflect the correct trans relationship expected from epoxidation followed by acid-catalyzed ring opening. Therefore, the correct answer is C. Therefore, the correct answer is option C.